HSR Company is a Taiwan-based manufacturer specializing in automotive rearview mirror glass. For more than 21 years, we have focused on the development and production of rearview mirror glass. Through continuous research in optical engineering, material science, and nano multi-layer Sol-Gel coating technology, we have redefined the value that a rearview mirror can provide. What we produce is more than rearview mirror glass. It is an optical technology designed to control light with precision, clarity, comfort, and safety. They all begin with the control of light. Is a rearview mirror simply a piece of glass that reflects what is behind the vehicle? In reality, the clarity, glare, and distance perception experienced by the driver can change significantly depending on how light is controlled. Through nano multi-layer Sol-Gel optical coating technology, HSR creates new visual value for rearview mirrors. In many markets, rearview mirror glass is still regarded simply as a processed sheet of glass. However, from the perspective of optical engineering, this understanding is incomplete. What truly affects driving safety and visual quality is not the glass alone. What matters is how light is controlled. The essence of an optical product. It is not only the material, but the design. When we look at world-class optical products, their value does not come from the glass material alone. Their true value is created through precision optical design and multi-layer coating technology, which control reflection, transmission, and optical interference. Even when the same glass material is used, different optical designs and coating structures can produce very different visual results and optical characteristics. This is the fundamental difference between optical products and ordinary industrial products. The real value is not only in the material itself. It lies in how light is delivered to the human eye in a more efficient, comfortable, and safe way. That is the essence of an optical product. HSR's core technology. Nano multi-layer Sol-Gel optical coating. The products we develop are not conventional tinted mirrors. They are also different from ordinary single-layer vacuum-coated mirrors. Our core technology is nano multi-layer Sol-Gel optical coating. Through a chemical Sol-Gel reaction, nanoscale thin film structures are formed on the glass surface. Thin films with different characteristics are then stacked in multiple layers to create an optical system capable of precisely controlling the light spectrum. This is not simply a surface treatment that changes color or appearance. It is an optical engineering technology that directly designs the behavior of light. The essence of multi-layer coating. It is not color, but optical interference control. Most traditional mirrors change their visual appearance through reflection or absorption. HSR multi-layer optical coatings work differently. They use the phenomenon of optical interference. By precisely stacking materials with different refractive indexes, the reflection and transmission characteristics of light can be adjusted. This makes it possible to achieve selective reflection of specific wavelength ranges, reduction of glare from high-intensity, high-color temperature LED light, reduction of stray light and irregular reflection, preservation of necessary visual information. In other words, the objective is not simply to darken the entire field of view. It is to help the driver recognize necessary information more easily, even in strong light conditions. HSR Nano Multi-Layer Sol-Gel Coating Structure. Blue Mirror. The blue mirror adopts a 6-layer nano multi-layer Sol-Gel optical coating structure. The 6-layer optical coating system is designed to reduce discomfort caused by harsh light while maintaining natural brightness and good visibility. It also preserves the visual information required to recognize vehicles, surrounding conditions, and distance behind the vehicle.
It is suitable for daily driving, highway use, and a wide range of normal driving conditions. Yellow Mirror. The yellow mirror adopts an 8-layer nano multi-layer Sol-Gel optical coating structure. Based on the basic structure of the blue mirror, 2 additional optical control layers are added. Through a more complex spectral design, it is intended to provide greater visual comfort under conditions such as glare from high-intensity LED light, nighttime driving, rainy weather, poor visibility, and low visibility environments. Therefore, the yellow mirror is not simply a different colored product. It has a different coating structure and optical design from the blue mirror, with the purpose of providing more advanced spectral control. The difference between the blue mirror and the yellow mirror is not merely color.
It is the difference in optical characteristics designed for different driving environments. 3 core visual benefits. 1. High clarity. By reducing stray light and unnecessary reflection, the mirror provides a clearer and more stable image. It is designed to improve image clarity, object edge recognition, distance judgment between vehicles and surrounding objects. This helps the driver understand the situation behind the vehicle more naturally and consistently. 2. Visual comfort. HSR optical coatings do not simply reduce the overall brightness of the mirror. They adjust spectral characteristics and control the light components that are more likely to cause discomfort and glare. This helps reduce the visual burden caused by highly stimulating light sources and contributes to greater comfort during long-distance driving. The objective is to reduce visual discomfort while preserving as much necessary brightness as possible. This is HSR's definition of visual comfort. 3. Optical anti-glare performance. True anti-glare performance is not about making the entire view darker. It is about selectively controlling the light components that cause discomfort while preserving necessary visual information as much as possible. The system is designed to manage light from sources such as high-intensity, high-color temperature LED headlights, high-D headlights, strong reflected light from road surfaces and surrounding objects. This helps reduce glare while making nighttime images and surrounding road conditions easier to recognize. Reduced glare. Preservation of the necessary field of view. Maintenance of nighttime image information. Easier distance perception. This is fundamentally different from an ordinary dark-tinted
window
mirror.
tint. It is not the same as optical anti-glare performance. In Indonesia and many other Southeast Asian markets, dark window tint is widely used to reduce strong sunlight and interior cabin temperature. As a result, some people believe the cabin is already dark, so an anti-glare mirror is unnecessary. In reality, dark window tint and optical anti-glare mirrors perform different functions. Window tint reduces the quantity of light. Window tint mainly controls the transmitted light entering the cabin. By reducing the amount of incoming light, it lowers overall brightness. However, when all light is reduced equally, certain conditions may also result in reduced visibility of nighttime details, lower visibility in dark areas, increased difficulty in rainy conditions, greater visual burden during long-distance driving. In other words, window tint reduces the total quantity of light, but it does not selectively control only the light responsible for glare. HSR controls the quality of light. HSR Nano Multi-Layer Sol-Gel optical coating does not simply reduce all light. It selectively controls the light components that are more likely to cause uncomfortable glare. The objective is to reduce glare while preserving necessary brightness and visual information as much as possible. This is the fundamental difference between dark window tint and an optical coated mirror. Window tint mainly controls the quantity of light. HSR focuses on controlling the quality of light. Limitations of OEM vacuum-coated mirrors. Many OEM rear-view mirrors on the market still use metallic reflective layers produced through vacuum deposition. Vacuum coating is a mature and widely used manufacturing process that provides stable reflectivity and high production efficiency. However, conventional metallic reflective layers may also have the following characteristics: relatively high reflectivity, more direct reflection of light. High-intensity LED white light may feel stronger. Strong reflection, glare, or light blooming may occur under certain conditions. In recent years, more vehicles have adopted high-intensity LED headlights. As a result, glare from vehicles behind has become more noticeable during nighttime driving. Even when dark window tint is used, glare and visual discomfort may not disappear completely. This is because the total light quantity may be reduced, while the optical characteristics of the light itself are not precisely controlled. The difference of HSR Nano Multi-Layer Sol-Gel optical coating. Through a nanoscale multi-layer interference structure, HSR performs selective reflection, selective suppression, optical control according to different wavelength ranges on light components that may cause uncomfortable glare. At the same time,
The system preserves as much necessary driving information as possible. Necessary brightness, nighttime image details, clear visibility, information required for distance judgment. Therefore, what the driver experiences is not simply a darker view. It is a clearer view of necessary information while glare is reduced. This is the value of the optical anti-glare performance pursued by HSR. Why optical-grade glass substrate also matters. Advanced optical performance cannot be achieved through coating technology alone. The performance of the coating is also directly influenced by the quality of the glass substrate. Optical-grade glass differs from ordinary glass in areas such as surface roughness, flatness, surface waviness, internal stress, impurity control. These factors directly affect image quality, light scattering, coating uniformity, film adhesion, final optical characteristics. Therefore, if the glass substrate is not suitable for optical use, even an advanced coating cannot fully deliver its intended performance. Optical performance is never determined by the coating alone. The glass substrate, coating design, production environment, and thermal treatment must work together as a complete system.
Why this technology is difficult to replicate. Nano multi-layer Sol-Gel optical coating is not a single-step manufacturing process. It is a complete optical engineering system that integrates multiple technologies. The manufacturing process requires nanoscale film thickness control, a highly clean production environment, temperature and humidity management, thermal treatment to form the coating structure, interlayer stability management, coating uniformity control. Furthermore, every layer involves optical calculation. Every film thickness has a design purpose. Every material has a specific function. Every layer affects the final optical characteristics. This technology requires the integration of optical engineering, material science, chemical engineering, nano-coating technology, thermal treatment technology, precision quality control. For this reason, many products on the market still use tinted mirror glass, single-layer coatings, vacuum-deposited color layers. These methods can change the appearance and color of a mirror. However, that does not necessarily mean that light is being precisely controlled. Conclusion: what we produce is more than rearview mirror glass. It is a complete visual optical system that integrates optical design, spectral control, optical-grade glass substrate, nano multi-layer Sol-Gel optical coating technology, material science, precision manufacturing management. The function of a rearview mirror should not be limited to reflecting what is behind the vehicle. It should also control harsh light, clearly transmit necessary visual information, and support the driver's safety awareness. A blue mirror is not simply a blue-colored mirror. A yellow mirror is not simply a yellow-colored mirror. Each is designed with a different coating structure, spectral design, and optical characteristics for different driving environments. The clarity, softness, and reduction of glare that you experience do not come from color alone. They come from the precision control of light. What we produce is more than rearview mirror glass. What we control is light.